Hello, I am Kaylin Brennan, and this is for Mr. Kilker's third period chemistry class, applied chemistry class, for our final project. I'm making caramel to show a decomposition reaction because my project is on chemical reactions. So the first one we learned about, the first chemical reaction we learned about, is a synthesis reaction, which is when two separate elements come together to form a compound. One major rule that kind of goes over like most of the 5 that we learned about is you never ever ever carry over subscripts. So the next reaction we learned about is a decomposition reaction, which is why I'm making the caramel. So I'm gonna go and do that and explain that to you while I'm doing that. Yeah. So, move location so you can see better. This is my pot. This is a medium-sized pan. Or actually, no, I lied. This is the larger pan I have. Basically, I'm going to be showing you what you need to make caramel because I realize that that's probably pretty important. So first, you need sugar. 1.5 cups of normal table sugar, granulated sugar, and then 1/2 cup of brown sugar. Then you need 1.5 cups of evaporated milk, which is about 12 ounces in a can. Next you need about 1.5 cups of heavy cream because, well, it's supposed to be heavy cream. I have 1/2. Let's hope that works. That's all I have. Then you need 3/4 cup light corn syrup. It has to be light corn syrup. I think that's what I have. Yeah, I have light corn syrup. Then you need 1/2 cup unsalted butter. Then 1 teaspoon of salt and 1 teaspoon of vanilla extract. And also 8x8 pan lined with parchment paper and a candy thermometer. That's what's most important. Yeah. Okay, so I am in my second step of caramelization, which is basically it's oligomerization. I don't know how to really say that. It's of fructose and glucose. So in this step, the caramel starts to turn brown, like darker than it was, and then glucose and fructose combine into one molecule again, which, could that possibly be a synthesis reaction? I don't know that for sure. I'm just like throwing that out there, why not? And as the molecules in one hydroxyl group and hydrogen of the other combine, they leave as water. So it's basically dehydration. It like dries out the thing, it, hardens more, thickens, and it leaves the molecules as caramel. So basically right now I am just stirring my, mixture, my caramel here, with the candy thermometer on the side, waiting for it to get to 245 degrees, which I'm like 50 degrees away from. I think a little bit more than that. So now it's just waiting and sitting here and stirring for a while. Hi. So, it's next night. The caramel has sat for like almost 24 hours now. So like you'd think, it'd be all the way hard, but I did use 1/2 and 1/2 instead of heavy cream. So it turned out like a little bit weird. It tastes really good, can't say, but it worked a little weird because it's still like really soft. So also I have a bunch of little tiny burns all over me because of the thing splattering on me, but it's okay. Yeah, so just wanted to say how that turned out. So it's the next night. Sorry for the change in setting again. It's my bedroom. Basically, after the decomposition reaction that we learned about, just all the caramel stuff, we learned about combustion reactions. You can either have a complete combustion or an incomplete combustion, where it really, the only difference I can see here in like the example I wrote down is that one of the subscripts wasn't carried over in the incomplete combustion. So I think that's what it is. It's basically when you take something like hydrocarbon and oxygen, make it into CO2 and H2O. Incomplete combustion, the only difference I have written down is it's CO plus H2O. That's what I have for that one, for a combustion reaction. For number 4, we learned about a single replacement combustion, which is basically changing one of the things. Like the thing I have is A plus XY goes to X plus AY. So it's changing, it's like flipping one thing and only one thing in the equation. Or not equation, kind of equation. And then there's a double reaction, or not double reaction, double replacement, which is basically changing two things in the like equation element stuff. So it's like having like AB plus XY that changes to XB plus AY. So it's switching. Basically, it's like flip-flopping. That's basically like everything I have written down to talk about. Yeah. So